Your Highnesses, Your Excellencies, ladies and gentlemen, it is just fantastic to have the world of AI back in Riyadh for the Global AI Summit. GAIN 2024 is all about the latest developments on AI now, next, and never. And when it comes to AI next, no topic is more exciting than artificial general intelligence. Because AGI is considered to be AI's next big frontier. When artificial intelligence reaches or surpasses human intelligence and cognitive abilities on a wide range of tasks. But artificial general intelligence is also a controversial topic. For example, is AGI at the brink of reality, or will it remain a distant horizon? Will AGI transform our world and provide benefits to society like nothing else before? Or will it turn into an existential threat that might even be humankind's last invention? This is exactly what we want to discuss in this session today in order to look at AGI from different perspectives and to provide you with a sneak peek into what the future might hold. It is therefore my pleasure to introduce to you Antoine Blondeau, Professor Simon See, and Alex Smola. Antoine is a co-founder and managing partner at Alpha Intelligence Capital. He is a visionary entrepreneur and tech investor with deep AI expertise. Simon is an adjunct professor at Coventry University and deeply involved in AI research. He is also a senior director and chief solution architect at NVIDIA's AI Center. And Alex is the CEO of Boson AI, which is heavily focused on large language models for entertainment and human interaction. In addition to this, he has also worked for many years at Google and AWS. Thank you all very much for being here today, and without further ado, let us get started. First of all, Simon, can you please tell us what exactly is AGI and how does it differ from the level of artificial intelligence we have today?
So I'm going to take a jab on this because when you ask 10 scientists about what is AGI, they'll give you 20 answers. So from my perspective, the key word is general. So at the moment right now, artificial intelligence is narrow. It can solve certain tasks narrowly. AGI basically means that it's generalized. It's able to understand, it's able to reason, it's able to adapt, and taking from concepts from other domains and apply it to different domains. So that is my definition of AGI.
Building upon this definition, let's talk about what it takes to reach AGI. In a just published BCG white paper, we have identified certain barriers and foundational requirements for achieving AGI. This includes, on the technology side, for example, computing power, algorithmic complexity, or also energy consumption. But we have also highlighted the needs for massive investments and ethical frameworks. Antoine, you have been involved in developing the technology that later evolved into Apple's Siri. What do you believe are the biggest barriers for achieving AGI?
So, look, we're in this great age where we've seen the emergence of LLMs, which are remarkable things, remarkable. But they are nowhere near AGI, and let me explain why. We humans, we learn on life. 95% of our learning is video. It's sound-enabled video. That's the way we learn. From the moment we're born until the moment we die, this is how we learn. Okay, we learn a bit on text. 5% perhaps of our life, we read books, we go to school, there's a bit of text-based learning. But all of our life essentially is this. It's learning on video. We will not achieve higher higher levels of intelligence with machines if we don't get machines to learn on video. And today it's very hard to do so. It's extremely hard. Machines today are learned, including on video, they are tasked with trying to predict how the next pixel looks like. So if we have 5 white pixels, is the next pixel going to be white as well? This is not the way that we humans learn. And so learning on video is the first task. And if we learn on video, then many things happen. If you learn the semantics of video, many things happen. We know humans that a hand has 5 fingers, right? We can know that. This is the semantics of a hand, 5 fingers. If there's one finger missing on that video, well, chances are that this is an atypical human, or maybe a bird, or a dinosaur, or an alien. We know, right? So learning the semantics of videos are critically important, and machines are nowhere near that. The second thing that will happen when we start to learn on video, when I say we, machines, start to learn on video, is we're going to start to learn what time means. We humans understand time because we live in it. Mm-hmm. We have an acute understanding of what it means, sequences, consequences, causality, and planning comes with understanding of time. Machines don't understand time as long as they just read text. When they begin to learn on video, and they can see that there's a car here, there's a pedestrian here, and if they converge, there's an accident. If they can learn on that, the semantics of that, then they will learn how to plan. And if they learn how to plan, they will learn how to reason in order to plan properly. And that's a huge topic. We're nowhere near getting there. It's a huge axis of research. And when it happens, brace for impact, because there'll be the rate of improvement in machine intelligence is going to be huge.
Very good. Simon, do you overall agree with this view? And what is NVIDIA doing to overcome the barriers towards AGI?
Well, one of the things is that when we look at the current technology, many people think that the large language models can be used, will be a path towards AGI. We have not really understand it. We are only in the verge of developing the large language models, and recently, because we are able enough data, we train it big enough, and it's something called the Grokkering effect, where of all of a sudden there's the emerging abilities, data that's produced. But we are still yet to really understand how it actually works. Now, in our perspective, right, many of the works that the communities are working on is to able to develop something that is both combining different things together. One of them is to use neurosymbolics, combine things that we have developed many, many years ago, things like to predicate calculus and whatsoever, to combine them together, to do understanding, to do reasoning. And then using large language models, combining it with large language models and with many other technology, then there is a potential path towards AGI. Relying on one single technology is, in my opinion, is not the way to go.
And Alex, you are working on large language models. How do you believe will large language models help on the path towards AGI?
So this is actually something that's been, I would say, quite miraculous and maybe a little bit surprising, how effective models that are able to predict the next word, the next token, have become in also being used for instance, understanding images, understanding voice, producing voice. And one trend that's been quite big in the past, maybe 12 months, is to convert everything into tokens, as in visual tokens, audio tokens, but also then to generate the appropriate tokens from that same sequence model. So there are papers in the past 12 months on using these models even for things like time series prediction, and they have worked unreasonably well. So this is good news, because to some extent we've started to exhaust the amount of available text. So it's a bit of back of the envelope calculation gives you that there's maybe about 100 trillion tokens text out there that would be probably human usable for LLM building. Out of those 100 trillion, the latest generation of models uses about 15 to 20, so a lot more will come by just going and scraping sources for audio, books, and maybe harder to access sources, but I think we've started to exhaust the supply there. There's still a very large supply of audio, and there's a very huge supply of video. So I think at some point this will play in. And I think it's going to be a bit of a function of how much NVIDIA and how quickly NVIDIA and maybe other companies produce the chips that are capable of processing said quantities of other modalities to combine that all into a model. But the backbone is probably going to be sequence modeling for the next foreseeable future, because we've seen a very convergent evolution of data, such as text, hardware, and also statistical models towards a very similar architecture, basically next token transformer structure prediction. And that's just worked unreasonably well, so let's see how far that goes for the next few years.
Very good. And talking about the barriers towards reaching AGI brings us naturally to the most popular and most debated question about AGI. When will it be achieved? Now, there are prominent stakeholders like Elon Musk, Sam Altman, or Ray Kurzweil, who predict that AGI will be achieved already within this decade. Some say as early as 2026. On the other hand, there are experts like Turing Award winner Jan LeCun, who believe that it's still decades away, and yet others believe it might never be achieved. The three of you are at the forefront of AI, and you have insights like almost no one else, through your work, through your investments, and through your research on AI. So please tell us, what is really happening, and what is your personal expectation on the timeline towards AGI?
So maybe I can start. So Jan is a good friend. He's an advisor to our fund, and we happen to be an investor in OpenAI. So we are sort of the two sides of the debate here. Look, first of all, in my view, it's a foregone conclusion that machines will eventually outperform humans. It will take a while, but it will happen. It is just logical, physically logical, that this will eventually happen. To get there, an enormous amount of science still has to be done. Per what Simon said, it cannot be a single model. It probably is multi-model. And as I said, we have to get machines to learn on the real world, just like we humans do. Observe, develop hypotheses, prove or disprove this hypothesis, and then generalize. To achieve that, 3 years ago, I would have said, not in my lifetime. But now, with what happened the last 3 years, I think it is possible that it does happen within 10 years, within 20 years, within that time frame. It's unthinkable, to be honest, to believe that, but the rate of progress is so intense right now that it's hard to predict 3 years out, let alone 15 years out. But my guess is that we're looking at 10, 20 years perhaps, where we see machines that are holistically as good as humans.
Very interesting. Simon, what's your take on this?
So every time anyone who asks me a question like this, my prediction is always wrong. But however, our attempts to do that. First of all, we look at all the different technology. The foundation models are growing tremendously. A lot of efforts is going into it. The combining different technologies are also progressing tremendously. DeepMind recently released this alpha proof, where combine the lean programming models together with language models together with reinforcement model, which allow us to do mathematical proving through artificial intelligence. There is recently, again, new publication and new work coming out from with open researcher, AI scientists, and whatsoever. So we are very close. Now, maybe we are able to achieve the 80% of it within this decade. The last 20% of it is going to be extremely challenging because there are many other things. We cannot continue on to build bigger and bigger model because we are not able to build unlimited amount of power. So we need to think of ways of doing that, things like continuous learning, dynamic adaptations, all the different type of technology. We need to actually take a look at it and then embed into this. All these things are still in its infancy, right? So we need to put that in perspective. So the last 20% is going to be take a longer time, but 80% of it, I think in this decade, we are able to achieve it.
So to me, this entire thing, whether we reach AGI, feels a little bit like the journey of are we there yet? And it's been a sequence of amazing features over the past 20, 30 years. So it started with things like, can we build a system that plays backgammon? To, can we beat a chess grandmaster? Good, can we beat Jeopardy? Can we play Go? Can we recognize a cat on an image? To, by now, can we produce language, right? Can we synthesize a voice such that it sounds human? So all of those things are steps on the path towards AGI. And I think for any given technical challenge or any capability challenge, we'll get there. And I think we can actually, for any of those things, map out a very clear developmental plan until we will reach this. Whether we will reach AGI as a universally competent, intelligent system that learns and improves on its own, I would say probably not for the next 10 to 20 years. At the same time, well, we have systems in our labs that you can talk to with voice and they can respond and you can interrupt, and sometimes it feels a bit like playing God. But it's very, very dangerous to think that this is actually a truly intelligent system. These are systems that are being prompted to do certain tasks, and they do them well, but that's very far still away. So TLDR, probably another 10 to 20 years at least, and there's still going to be a lot of exciting challenges to come, which is why this is fun, right? But it's an exciting time now.
But let's talk also about the risks and benefits of AGI. Obviously, from a risk perspective, this ranges from ethical concerns through job displacements to even the fear of losing control when AI becomes more autonomous. Nevertheless, individual companies and whole countries are racing towards AGI in the expectation of massive gains and benefits for society. What are your biggest concerns when it comes to AGI, and which benefits do you foresee? Maybe Alex, this time you start, please.
So I'm not afraid of AI in this case. I'm afraid of humans using it really for nefarious purposes. You can use it, for instance, for large disinformation campaigns. So where before that you needed hundreds of humans to post fake posts on social media, now one or two talented PhD level engineers can build such a system, and they can do a lot of damage. We can use AI to understand what people say to each other and try to control this and steer it in various purposes. This can be used for safety purposes. So if I know that somebody is going to, kill somebody, then I should probably intervene. But you can also use it for less charitable purposes. So I'm a lot more worried about humans using AI for purposes that are maybe not great. I'm not afraid of AI for now, at least not for the next 10 to 20 years.
Do you have the same view, Simon? And please ask for a brief answer, please.
Well, my concern is that people become complacent. And we trust, we have a perception that AGI is going to give every single answer correctly. And then we start not to do critical thinking. And that is my major concern.
Understood. Your Highnesses, Your Excellencies, ladies and gentlemen, I think we have for sure exciting times ahead of us. But for now, please join me in thanking Antoine Blondeau, Professor Simon See, and Alex Smola for their insightful contributions and congratulations to Sedaya on the perfect organization of this wonderful summit. Thank you very much.